Hey all, today we're going to continue a discussion about reasoning. We already talked in the first lesson in this unit about inductive reasoning, which was following patterns. And this time we're going to talk about deductive reasoning, using what you're given to draw a conclusion. So make sure you add this to your concept list. So we're going to add a couple things to our flipbook. The first one would be the law of detachment. So this goes on the outside. And then on the inside we put all this stuff. So the law of detachment is when you're given two different things. You're given a conditional statement, so an if P then Q, an if then statement. And then you're also given an example, a true example of P, the hypothesis, the beginning of that if then statement. So if you're given the combination of a if P then Q, and then you're given an example, a true example of P, the hypothesis of that conditional statement, then you can draw this conclusion about the conclusion of the if-then. And just like it's been throughout this unit, this is going to make far more sense when we do an example, but it's important to get this into your book. We're also going to add the law of syllogism, and this time we have two conditional statements. So we have a P then Q, and then we have a Q then R. R is just the hypothesis of a second statement. Notice that Q is at the end of the first one and the beginning of the second one. So what I have are two conditional statements, one that starts the way the other one ends. And when I have that scenario, I can make this conclusion, and I can basically cut out the Q portion of both of those statements and combine P with R to make a new if-then statement. So let's see these in action, and it'll be a little bit easier to understand. So I've given you an example of how it works, and then an example of how it doesn't work. So let's talk about the way it works for detachment. Here I have an if-then statement where my hypothesis is it rains, and my conclusion is football will not practice. And then I'm given a statement down here, it rains on Wednesday. So it's raining on Wednesday. That is an example, a true example of it raining, of the hypothesis of the original conditional statement. So since this statement, it rains on Wednesday, matches the hypothesis of our conditional statement, then we can make a conclusion that football will not practice on Wednesday. And you can see that that conclusion is about the conclusion of the original conditional statement, football not practicing. And we added the context that came from this statement number 2 that we're talking about Wednesday, so we'll say that football will not practice on Wednesday. Here I have the same idea. I have the same conditional statement about it raining and football not practicing. And here this says that football is not practicing on Saturday. So this statement here is an example of the conclusion of the original conditional. So this won't allow us to make any special conclusions about these two statements combined. Football not practicing on Saturday might be because football just played a game on Friday, or they canceled practice because it was too hot out. Okay, so we can't make any conclusions, so we would say cannot make a conclusion, or we can say no conclusion can be drawn. So pause here and give these two a try. It's probably not necessary to write all this down, but it is necessary to write down your answer. So in this first one, I'm telling you that you should be able to draw a conclusion. My hypothesis is two angles are vertical. It shouldn't say if two angles are vertical. It should say if two angles are vertical. Sorry about that. And my conclusion is they are congruent. So I need this second statement to be about the hypothesis, or the beginning of my first conditional, and it is angle 1 and angle 2 are vertical angles. That's an example of two angles being vertical. So my conclusion is going to be based on the conclusion of my if-then. And so I can say that angle 1 and angle 2 are congruent. Down here, I have same hypothesis, same conclusion. I made the same typo. But now my second statement is about the conclusion of the conditional. So there is no conclusion that we can draw from these two statements together. In fact, angle 1 and angle 2 could be congruent without being vertical angles, so that's why we can't make the conclusion that they are. So let's try an example of syllogism. Again, this is where I have two conditional statements. So again, I'm giving you an example that works, and I'll give you an example that doesn't work. So I have my football rating example again, to be consistent. So there's my hypothesis, it rains. Football will not practice is my conclusion. Down here, the beginning of the second conditional is football does not practice. That's the same as the end of the original. So I'm going to highlight it in the same color. And then I have a third part, the team will lift weights. So because the end of my first statement is the same as the beginning of my second statement, I'm sort of going to cut out the middleman here, and I'm going to eliminate the parts in green, and I'm going to combine the other two together to get, if it rains, then the team will lift weights. So let's check this one out and see why it doesn't work. Staying consistent with my example. Here, my second conditional starts with the original conditional's hypothesis, so they start the same way. So this is not going to work for the law of syllogism. They both start the same way. I need one to end the same way the other one starts, so there can be no conclusion drawn here. So go ahead and pause here, give these two a shot. So here I have two conditionals. I got P and Q. Cutting an angle in half is the Q. The end of my first statement, it's also the beginning of my second statement. It's worded a little bit different, but they mean the same thing. And then I have this other piece. So again, what I'm going to do, because the first one ends the same way the second one begins, is I'm going to sort of cut those two pieces out. And then I can combine the beginning of the first statement with the end of the second to get, if array is a bisector, then the smaller angles are congruent. Down the bottom, I told you it shouldn't work, so we have to figure out why not. The second statement starts with if angles are the same size. Angles being the same size were not part of the first statement at all. And then being congruent is also new. So these are four different things here. So none of it lines up to where the end is the same as the beginning, so we can't draw any conclusions. Okay, so I have a link again, and a couple for you to try. So click the link, log in, submit your answers, and then let's see your notes.